So, one theorem. Let G as a tuple be a graph. Then the sum of the degrees of the vertices is equal to twice the number of edges. And the proof of this is very simple. Why is that? Well, because as we count degrees, well, every time that we count an edge, we're counting towards the degree of two vertices. And, well, boom, that's it. Now, this imposes some conditions. For example, there are no graphs with an odd sum of degrees. Right? It's impossible. The sum must be even. Now, something else that I want to introduce for this video is the following, the notion of isomorphism. Because we are supposed to be able to compare graphs, and the idea is how is that we can distinguish them. And to do so, let me say the following. Let G1 and G2 be graphs. We say that G1 is isomorphic to G2 if there is a one-to-one correspondence F from the set of vertices V1 to the set of vertices V2 with the following condition. The pair FV1, well, VFU belongs to the set of edges of the second graph if and only if I have this associated edge in the first graph. Now let me give you an example for that. Let's say that I have these graphs, a pentagon versus a star. Can we say that these two are isomorphic? In fact, they are. Let me do the following. I'll introduce a labeling, and then over here I'll introduce a labeling induced. So I have 1, 2, 3, 4, 5. Over here, I will write it this way. 1, 2, 3, 4, 5. Now, the pictures are really different, but the graphs are the same, essentially the same. They have the same form. So one of the main problems, if not the main problem of graph theory, is how is that we can distinguish among non-isomorphic graphs? So graphs that are truly different. And here is another example. The following are not isomorphic.